Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class we are going to revise midterm syllabus of mathematics. You all know that in mathematics, so far we have learned the first 7 chapters given in NCERT text, right? And these chapters are written on the board. Please go through them. First one is number systems, second one polynomials, third one coordinate geometry, fourth one linear equations in 2 variables, fifth one introduction to Euclid's geometry, sixth one lines and angles, and seventh one is triangles. Then shall we go for revising these lessons one by one? Okay. Before going to that, just let me give you 2 important instructions. Please do follow them. The first one is get ready with the material, notebook and pen. And second one is, as it is revision class, myself and you all should go hand in hand. That means when during the explanation, whatever I am going to write on the board, the same thing should be copied by you all simultaneously. Got it? Yes. Let us begin. Before that, you just copy as it is this part, as well as write the name of the first chapter. Yes. Now let's go for revising the concepts one by one. Then could you tell the first concept in the chapter number systems? Very good. It is different types of numbers. They are, one is whole number, natural numbers, whole numbers, integers, rationals, irrationals and real numbers. But among these, the definition of one type is important, which is that, very good, it is rational number. You all know that the collection of rational numbers is denoted by the symbol, it is Q. Then could you tell the definition of it? Yes, a number which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called a rational number. Then we can give plenty of examples, 1 by 2, 3 by 7, 11 by 4, minus 2 by 6 and so on. Next, what is the second concept related to these rational numbers? It is finding the rational numbers between 2 given rationals. Then shall we go for that? Yes. Here I write, find any 4 rationals between 2 by 21 and 5 by 6. Look here we have 2 rational numbers which are in fractional form. In such case, first we will go for taking the LCM of the denominators. Right. LCM of 21 and 6 is how much? Very good. It is 42. If you do not know that, you can go for working out in the working column. Next step. Now we have to write the equivalent fractions of these. Hence, such that the denominator should be 42. That is why, to find out the equivalent fraction of 2 by 21, we have to multiply this numerator and denominator by same number. How do you find out that number? Very good. 2 by 21 should be multiplied by LCM 42. 1s are, it is 2s are. Now this 2 should be multiplied to the numerator as well as denominator. Now 2 2s are 4. 21 2s are 42. 4 by 42. Followed? Next. Let me take second one, that is 5 by 6. Multiply 42 to the number 5 by 6. Now cancel it. 1s are, 7s are. Multiply 7 to the numerator as well as denominator. It is 5 into 7 by 6 into 7. 5 7s are 35. 6 7s are 40. Got it? So these are the 2 equivalent fractions of 2 by 21 and 5 by 6. Between these 2, many are there. Like, that is 4 by 42. Between this and this, we have 5 by 42, 6 by 42 and so on. The last one is 35 by 42. But how many we want? We want only 4. Hence, let us write. Therefore, 4 rationals between 2 by 21 and 5 by 6. 2 by 21 and 5 by 6 are, what are these? Write from here. 5 by 42, 6 by 42. Even you can write it in simplest form. 7 by 42 and 8 by 42. Got it? So this is the second concept. Now shall we move on to third concept? Yes. Dear students, in the third concept, we will go for learning about irrational numbers. You all know that these are the numbers which cannot be expressed in the form of P by Q with a condition P and Q are integers and Q is not equal to 0, right? And irrational numbers is denoted by the symbol Q dash. Use some example. It is root 2, root 3, root 7 and so on. And with respect to this, we have learnt an important concept, that is representing irrational numbers on the number line. Actually, we have two important methods. Yes, one is spiral method and another one is vertical method. Now, let's go for recalling one by one. In that, first one is, we are going to represent root 3 on the number line by spiral method. Right. Represent root 3 on the number line. Very simple. First you take scale, pencil and compasses. First draw a straight line and go on marking for every 2 centimeter. Then you may call this point as 0 and right side of 0 are positive. 1, 2, 3, 4 and so on. Left side are negative, minus 1. At 0, you may call this point as A and 1 as B. The distance from A to B, call this as 1 unit. Followed. Next, at B, construct 90 degree. Yes, I'll go for taking the protractor. Okay, like this. At B, mark against 90 degree. Then draw a straight line. Yes. Then this is the perpendicular. Now, you take a distance of AB using compasses like this. Distance AB. Then that is 1 unit. With B as center, draw an arc which cuts the perpendicular at point. You call this point as C. What is the distance from B to C? It is also 1 unit. Followed. Next, join AC. Next, do you know what is the distance from AC? It is root 2. How? By using Pythagoras theorem for the triangle ABC, you can find out this. AC square equal to AB square plus BC square. 1 square plus 1 square, it is 2. AC equal to root 2. Next, but we are going to represent root 3 on the number line. Hence, at C, again place the protractor, midpoint of the protractor, mark against 90 degree. Draw the line from the point C, which passes through the, mark the point. Again, take compasses and take 1 unit distance with the C as center. Draw an arc which cuts the perpendicular at point D. What is the distance from C to D? It is also 1 unit. And join AD. It is A to D. What is the distance of AD? It is root 3. You can find out by using Pythagoras theorem. As we are going to represent root 3, hence I will show you how to get AD as root 3. You take the triangle ACD. In triangle ACD, you all know that angle ACD is 90 degree. So by using Pythagoras property, how do you go for writing? Very good. It is AD square is equal to AC square plus CD square. AC square plus CD square. What is AC? AC is root plus CD. It is 1 unit. Root 2 whole square is 2. 1 square is 1. This is 3. AD equal to root 3. Followed? Now, to represent root 3 on the number line, again take compasses and take the distance of AD with A as center, AD as radius, draw an arc which cuts the number line at a point. This is the point. This is root 3. This is how to represent root 3 on the number line. Even it can also be continued for root 5, root 7 and so on. Look at root 2, root 3, next root 4 will come, next root 5, root 6 and so on. And if you go on following this method, you will get a spiral. Hence it is called Theodorus wheel method or spiral method, also called square root method. Yes, go for this. Next, fifth important concept is, this is square root of a perfect square plus 1, and that should be represented on the number line by vertical method. Square root of perfect square plus 1. See the perfect square are, first one is 1 plus 1. Next, another one is 4 plus 1. Next one is, it is 9 plus 1. That means root 2, root 5, root 10. For all these can be represented on the number line by vertical method or direct method. Direct method. How it is? Let me show you. First, again take scale and pencil, draw a straight line and go on marking for every 2 units. Every 2 units. Now, you may call this point as 0. This is 1 minus 1. On right side of 0 are positive. 1, 2, 3 and so on. This is the number line. Again, call this 0 as A, 1 as B. What is the distance from A to B? Very good. This is 1 unit. Hope that you have written. At B, construct 90 degree. Take protractor. Place the midpoint of the protractor at B, mark against 90 degree. Then draw the line from B to the marked point. You will get the perpendicular. Look here. You are going to represent root 5 on the number line. Here I'll write root 5 on the number line. Look here. Here 1 unit. We know that root 5 is nothing but 4 plus 1. 4 is a perfect square. It is root 4 is 2 units. So here already 1 unit is there. Remaining we want 2 units. That should be marked on the perpendicular. Hence, now take compasses. Take a distance of AB. This is 1 unit. Next, with B as center, draw an arc. Call this point as C. Then with C as center, draw an arc of same radius. It is D. What is the distance from B to D? This is 2 units. Followed. Then join DA. How much it is? It is root 5. Can we show that on the with calculation? Yes. How? By using Pythagoras theorem. Look here. In triangle ABD. In triangle ABD, angle ABD is 90 degree. Use Pythagoras theorem. We can write AD square equal to AB square plus BD square. What is AB? it is 1. BD 2. It is 1 whole square plus 2 whole square, which is equal to 1 plus 4. 1 plus 4 is 5. Then what will be AD? AD is root 5. Got it? So this is root 5. But it should be represented on the number line. Again, take compasses, take a distance of AD with A as center, draw an R which cuts the number line at a point. This is root 5. Use compasses and draw like this. This is how to represent root 5 on the number line by vertical method. So these are just, I have given some numbers. Even you can also go for taking the next perfect square, that is 16 plus 1. Then root 17. Next one, 25 plus 1, root 26. Got it? Yes, copy that. Dear students, the sixth concept. What is that? It is representing square root of decimal numbers on the number line. You know that how to represent. Let's go for recalling this. Right. Represent square root of decimal number. Let us take, it is 9.8. Represent square root of 9.8 on the number line. This is also very simple. Even sometimes they will ask you to verify with calculation. Let me tell you that. Yes. Take scale and pencil. First, draw a straight line. Okay. Next, after that, mark a point at one end. Here, I am marking this point. You may call this point as A. It is square root of 9.8 is there. So mark 9.8 on the number line. 9.8. 9.8 on the number line. You call this point as B. Then after that, take one more centimeter. You call that point as C. Followed? Very simple. Whatever the number is given, you have to take that much centimeter on the number line plus 1. See, 9.8. So I have taken A to be 9.8 plus 1. 9.8 centimeter plus 1 centimeter. From here to here, this is 1 centimeter. Followed? Now it should be represented on the number line. The first thing is, take compasses, draw perpendicular bisector to AC, not AB. Please do remember AC. You know that how to draw perpendicular bisector. With A as center, take more than half of AC and draw the arcs on either sides. Got it? Here I am drawing. Next, don't change the radius. With C as center, draw the arcs. They cut previous arcs at two distinct points like this. Next, take scale and join these points with a dotted line. You will get the midpoint. Call this point as M. Next, again, you have to take compasses with M as center, AM as radius, like this. M as center, AM as radius. You have to draw a semicircle. Followed? Repeat it, I have been telling. With M as center, AM as radius, draw a semicircle. Followed? Next, at point B, draw the perpendicular. For that, use protractor and mark the point against 90 degree. Call this point as D. So that is, you have to draw the perpendicular from B it will intersect the semicircle at point D. Followed. Next, with look here, this is BD. BD is square root of 9.8. How do you believe that? Very simple. You have to show BD is 9.8 centimeter. Very simple. You have to join MD. Here I am showing the calculation. Look here. To find out BD, you can go for using Pythagoras theorem for the triangle MBD, right? In triangle MBD, hope that you are all writing with me. Angle MBD equal to 90 by Pythagoras theorem. Pythagoras theorem. We can write MD square. MD square is equal to MB square plus BD square. MB square plus BD square. Then what is MD? MD, look here. It is it not the radius of this semicircle? Yes. Then radius is half of the diameter. What is the length of the diameter? Diameter is, that is AC. Here I'll write for your reference, D, that is diameter is 9.8 plus 1. 9.8 plus 1 is 10.8 centimeter. But we want radius. It is 10.8 by 2. It is 5.4 centimeter. Followed. This is 5.4 centimeter whole square. MB. MB is how much? Look here. MB is, it is MC minus BC, where MC is radius. Radius is 5.4 minus 1. Here I will write. It is MB, it is equal to 5.4 minus 1, it is 4.4 centimeter. MB is 4.4 centimeter. It is whole square plus BD square. Then transfer 4.4 square to the left hand side. 5.4 whole square minus 4.4 whole square. It is equal to BD square. It is of the form A square minus B square. Can be written as A plus B into A minus B. That is 5.4 plus 4.4 into 5.4 minus 4.4 is equal to BD square. Because calculation will be easy by using the identity. 5.4 plus 4.4 is, it is 9.8. 5.4 minus 4.4, 1. It is BD square. 9.8 ones are 9.8. Then BD is equal to square root of 9.8. Clear? Here I will write square root of, BD is square root of 9.8. Square root of 9.8. Now it should be represented on the number line. Again, take the compasses, take a distance of BD and draw an arc which cuts the line at a point. This point is square root of 9.8. You all know that square root of 9.8 is more than it is more than 3, value 3 and less than 4. But where is 3 and 4? Not there. So that is why you should go on marking for every 1 centimeter. Look here. Here 0. This is 1. This is 2. This is 3. Here is 4. 5. 1 centimeter. Now 9.8 lies between 3 and 4. Hope that you all have understood. You have to practice this one. Dear students, in the 7th concept, we are moving to which one? Very good. It is about decimals. Then in case of decimals, we have different types, right? Okay, 0.125. What type it is? It is terminating decimal. That means there are countable number of digits in the decimal part. Now here 3.0 142857, 142857 and so on. It is non-terminating, right? There is no end at all. So this is terminating decimal expansion. It is non-terminating decimal expansion. In non-terminating, again we have two types. One is, look here, in the decimal part, 142857, 142857, it is being repeated. So therefore it is non-terminating, recurring or repeating, non-terminating, recurring decimal expansion. And another one is, if you go for writing, say 1.7325631123 and so on, there is no end at all. Non-terminating. And is there any decimal part is recurring? No. So we can say that it is non-terminating, non-recurring decimal expansion. Followed. Whereas in this case, that is non-terminating, recurring. I'll take, that is 22/7. It is a rational number. Its decimal expansion is 3.142857. 142857. There is no end at all. It can also be written as, that is, repeating block can be written as 142857 bar. Okay. And here, this non-terminating recurring part, in recurring decimal, we can find the length as well as period. Look here, length is how many digits are being repeated, that should be identified. 1, 2, 3, 4, 5, 6. So that is length. Length is 6. And period. Period means a repeating part. Which is the repeating part? It is 14285. Clear? Okay. Now let us come to know how to express decimal numbers in P by Q form. If it is terminating, it is easier, which you have already learnt in your previous class. And even we have also learned how to represent non-terminating recurring in the fractional form. In the 8th concept, we will learn that. Observe. 8th one, we will find out, or we will express some decimal numbers in the form of P by Q. Non-terminating recurring. Here, right, express 0.23 bar in P by Q form. Even it can be given for just 1 mark as well. In 1 mark, how do you write? It can be written as 23/99. But for 2 marks, you will have to follow certain steps. Yes, you should go on writing with me. First, you have to assume 0.23 bar as x, that x equal to 0.232323 and so on. You may call this as statement 1. Observe, in the repeating block, how many digits? How many are there? There are 2 digits. If 2 digits are there, multiply both sides by 100. 1 digit, multiply both sides by 10. 3 digits are repeated, 1000 should be multiplied. Here 2 are repeated, hence multiply 100 on both the sides. Then this can be written as 100 into x, 100x, and this is 100 into 0.2323 and so on. 100 and multiplying, it becomes 23.232323 and so on. Call this as 2. Now subtract 1 into 1 is x is equal to 0.232323. Followed. Now subtract this 100x minus 1x, it is 99x. Now here 3322, 3322, 3322 get cancelled. 3 minus 0, 0, 20. Anyhow, 23 minus 0 is 23. X is equal to 23/99. Is it possible to simplify further? No. What is x? X is 0.23 bar. Therefore, 0.23 bar is equal to 23 by 99. So this is the method of expressing non-terminating recurring decimal in the form of P by Q. Similarly, if 0.7 is there, 7 bar, how do you write? 7 by 99. If it is 0.001 bar, how do you write? This is 1001 by 999. Now I will go for taking one more example with respect to this. Here, this is a pure decimal. Now I am going to take impure decimal. See that this is 32.1235 bar. See, bar is applicable only for 35, not for 12. How to express this in P by Q form? Again, first we have to assume x equal to 32.1235 bar, or else 35, 35, 35 and so on. How many digits are there in the repeating block? 2 digits. Then what should be multiplied? Again 100. So multiply 100 on both the sides. Then this will be, it will be 100 into x, 100x. This is 3 2, next 1 2.35, 35, 35 and so on. You call this as equation 1 and this as equation 2. So 2 minus 1. So minus equation 1. X is equal to, it is 32.123535 and so on. Subtract. Here this will be 99x. This is, look at 0, 0, 0, 0. 5 minus 2, 3. 3 minus 1, 2. 2 minus 2, 0. Here from 1, 3 cannot be subtracted. Borrow 1. 11 minus 3, 8. Here 1. This is 3. 3180. Now x is equal to, it is, so 99 x equal to 318023 by 100, because after decimal we have 2 digits. Next, x is equal to 318023 by 99. See that, is it possible to cancel? 3 plus 1 4, 4 plus 8 12 plus 0 12 plus 2 14 plus 3 17. So 17 is not the multiple of 3 or 9, hence it is not divisible. Directly we can write 32.1235 bar is equal to 318023 by 99. Followed? Okay, now we are moving to another concept. Dear students, now we are moving to 9th concept. This is method of converting irrational numbers into a rational number by multiplying it with another irrational number. What is that? Very good. It is called rationalization. Rationalization. Then what do you call the number which is to be multiplied to the irrational to convert this into rational? It is called rationalizing factor. Generally we call it as a rationalizing factor. If it is binomial, if 2 terms are there, then it is also called conjugate. If it is so, could you tell what is the rationalizing factor of root x? It is root x only. Rationalizing factor of 2 by 3 root x, again it is root x. If it is root x plus root y, this is root x minus root y. If it is root x minus 2 into root y, this can be written as root x plus 2 into root y. Followed? What about square root of x plus y? This is just square root of x plus y only. Now I will take an example. The question will be given like this. Rationalize the denominator of a number will be given. Right. Rationalize the denominator of, here I will take one example. This is 1 by root 6 minus root 5. I have taken first very simple one. First, what you will do? Very good. You are going to convert denominator into rational number. So you have to take the conjugate of the denominator. What is conjugate of root 6 minus root 5? Very good. It is root 6 plus root 5. Then multiply this conjugate to the numerator as well as denominator of the given number. The given number is 1 by root 6 minus root 5 into here root 6 plus root 5 by root 6 plus root 5, which is equal to denominator. Observe in which form it is. It is very good. A minus B, A plus B. What is A minus B into A plus B? This is A square minus B square. Now this can be written as root 6 whole square minus root 5 whole square. Numerator, you may write this as it is 1 into root 6 plus root 5. So when you multiply 1 with any number, you will get the same, root 6 plus root 5. If other numbers are there, leave that as it is till the end, because there is a chance of cancellation. What is root 6 whole square? It is 6 minus root 5 whole square. It is 5. Root 6 plus root 5 by, what is 6 minus 5? 1. It is root 6 plus root 5. Followed? Then observe it. Rationalize the denominator. Denominator root 6 plus root 6 minus root 5. What is its rationalization? This is 1. Got it? Yes. Got it. Yes, students, this is another important example with respect to rationalizing the denominator. Go through the question. It is if 3 plus root 7 whole divided by 3 minus 4 into root 7 is equal to A plus B into root 7. Find A and B. Very simple. Here also we have to rationalize the denominator to find out A and B. Right? It is, the denominator is 3 minus 4 root 7. First let us take its conjugate. Conjugate of 3 minus 4 root 7 is 3 plus 4 root 7. Multiply this to the numerator and denominator. It is 3 plus root 7 by 3 minus 4 into root 7 into conjugate is 3 plus 4 into root 7 by 3 plus 4 into root 7, which is equal to RHS is, this is A plus B into root 7. Then observe the denominator. The denominator is of the form A minus B into A plus B. Apply the identity. By applying the identity A plus B into A minus B, we can write it as A square minus B square. And the denominator can be written as 3 whole square minus the second term is 4 into root 7 whole square. And go through the numerator term here 3 plus root 7 into 3 plus 4 into root 7. Hence, you can multiply 3 with both the terms, even root 7 with both the terms. 3 into 3, it is 9. Then 3 into 4 root 7, it is 12 root 7. Then multiply root 7 with 3. This is 3 into root 7. Plus root 7 into root 7, it is 7. 7 4s are 28, which is equal to A plus B into root 7. Next, look at the board. Here 9 plus 28, how much it is? This is 37. 12 root 7 plus 3 root 7. 12 plus 3 is 15 into root 7 whole divided by the denominator. Here 3 square is 9 minus 4 into root 7 whole square. Apply square to both the terms. 4 square is 16 and root 7 whole square is 7, which is equal to A plus B into root 7. Next, numerator, you may write this as it is, that is 37 plus 15 into root 7 whole divided by 9 minus 16 sevens are 7 6 are 42 4, 7 1s are 7 plus 4, it is 11, 112, which is equal to a plus b into root 7. Next, let me continue that here. It is 37 plus 15 into root 7 whole divided by, what is 9 minus 112. See, 112 minus 9 can be written as 12 minus 9 is 3. Here is 0, 1. 103. So minus 103, which is equal to a plus b into root 7. Now multiply this divide each term by 103. Here I write minus of 37 plus 15 into root 7 whole divided by 103, which is equal to a plus b into root 7. Then this can be written as minus 37 by 103 plus into minus is minus 15 root 7 by 103 is equal to a plus b into root 7. Now compare the coefficients. What is in place of a? It is minus 37 by 103, and in place of b we have minus 15 by 103. Root 7 is there. You have to leave that as it is. These are the values of a and b. Copy this. Dear students, the next important concept is about laws of exponents. We are very familiar with those, but they are to be applicable to irrational numbers as well. If you want to recall them, one is a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. If a raised to the power m by a raised to the power n, how do you write this? This is a raised to the power m minus n. If a raised to the power m whole raised to the power n is there, this can be written as a raised to the power m into n. Then similarly, if a into b whole raised to the power m, this can be written as a raised to the power m into b raised to the power m. Then if 1 by a raised to the power n is there, this can be written as a raised to the power minus n. That is, this exponent term is to be taken to the numerator. That is, denominator to numerator sign get changed. Even numerator to denominator, again the sign get changed. Remember this. Even one more, that is a raised to the power 0, it is equal to 1. Like that. Many are there. A raised to the power m by a raised to the b raised to the power m can be written as a by b whole raised to the power m. So we have solved so many problems regarding these laws of exponents, but here I have written only 3 which are very important. Just go through this and should go on writing with me. This first example, find the value of x if 6 by 5 whole raised to the power x, 5 by 6 whole raised to the power 2x is equal to 125 by 260. Just by observing this, you can come to know that 125 and 216, they are perfect cubes, right? 125 is a cube of 5, 216 is the cube of 6. 5 and 6. Here 6 by 5 is there. We have one more important identity, that is, if a by b whole raised to the power m is there, this can be written as b by a whole raised to the power minus m. Here this is 5 and 6. Here 5 by 6. And it should be 5 by 6. I am going to write the solution directly. It is 5 by 6 whole raised to the power minus x into 5 by 6 whole raised to the power 2x, which is equal to 125 can be written as 5 cube, 216 can be written as 6 cube. Observe here the bases are same and the powers are different. Hence let's go for adding them. 5 by 6 whole raised to the power minus x plus 2x, which is equal to, this is 5 by 6 whole raised to the power 3. Next, here 5 by 6 whole raised to the power minus x plus 2x is x is equal to 5 by 6 whole raised to the power 3. Observe, again here the bases are same and the powers are different, equate them. X equal to 3. This is the value of x. Go through second important fact. Here we are going to find out the value of this statement. 81 whole raised to the power 0.16 into 81 whole raised to the power 0.09. On observing, you can come to know that bases are same and the powers are different. Then what should be done? The powers must be added. Here also I am writing the solution directly. Here 81 whole raised to the power 0.16 plus 0.09, which is equal to 81 whole raised to the power. Add these two, you will get 0.25. Followed? Now, let us continue with this one. 81. Can 81 write this as it is, and 0.25 can be written as 25 by 100. Got it? Because decimal is converted into fraction. It is 1s or 4s or. 81 whole raised to the power 1 by 4. 81, it can be expressed with the power 4 like this. See, it is 81 is 3 27s are. This is 27 is 3 9s are. 9 is 3 3s are. 81 can be written as 3 raised to the power 4 whole raised to the power 1 by 4. It is equal to 3 raised to the power 4 by 4. 4 and 4 get cancelled, is equal to 3 raised to the power 1 is nothing but 3. So value is, it is 3. Next, here I have written third one. Here we found out the unknown term. In second one, we found out the value of the whole statement, whereas in case of third one, here we are going to prove the statement. So these are the three different types of question will be asked on laws of exponents. Go through third one. It is x raised to the power a minus b whole raised to the power a plus b into x raised to the power b minus c whole raised to the power b plus c. Then x raised to the power c minus a whole raised to the power c plus a equal to 1. So to prove this, first go for taking LHS. Write this as it is. X raised to the power a minus b whole raised to the power a plus b into x raised to the power b minus c whole raised to the power b plus c into x raised to the power c minus a whole raised to the power c plus a. It is equal to. When you observe each of the terms, you can come to know is of the form a raised to the power m whole raised to the power n. How do you go for writing this? It is a raised to the power m into n. Now first term can be written as x raised to the power a minus b into a plus b. Next, x raised to the power b minus c into b plus c. And third term, x raised to the power c minus a into c plus a. Again, you just observe the term which is in power. You can come to know that they are all of the form a plus b into a minus b, right? What is a plus b into a minus b? This is a square minus b square. It is a square minus b square into x raised to the power b plus c into b minus c. This is b square minus c square into x raised to the power c minus a into c plus a, c square minus a square. Now, these terms, they are of the form, another law of exponent, that is a raised to the power m into a raised to the power n, which is equal to a raised to the power m plus n. Here bases are same, powers can be added. X raised to the power a square minus b square plus b square minus c square plus c square minus a square. And go through this. Here plus a square minus a square get cancelled. Plus b square minus b square get cancelled. C square and minus c square get cancelled. What will remain in the numerator? It is 0. We all know that anything raised to the power 0, nothing but a raised to the power 0 is 1. Hence, x raised to the power 0 will also be 1. Observe what is in RHS? This is 1. So, LHS equal to RHS. Hence, it is proved. Followed? Yes. Dear students, one more important concept, and is also the last concept of this chapter, that is successive magnification. Nothing but representing the decimal numbers on the number line using magnifying glass. Look here. Here one such number is given, 4.125. You all know that 4.125, it lies between two whole numbers. What are those? See, this is more than 4 and less than 5. Therefore, we can write 4.125 lies between 4 and 5. That's why first we have to draw a number line. Okay, for every 1 centimeter I have marked. So 0 to 10 is written. This number lies between 4 and 5. I take this is 4 and this is 5. Using scale and pencil, you have to draw the line like this. This is 4.0 and between 4 and 5, this is 5. This is 5.0. Followed? And remaining can be written as it is 4.1, 4.2, this is 4.3, 4.4, 4.5, 4.6, 4.7, 4.8 and 4.9. But the number is 0.125. That means it is more than 4.1 and 4.1. See that 4.1 is here. This can be written as 4.10 and 4.2. Here we can mark 4.12, sorry, 4.10, 4.20. Now we can write it as 4.11, 4.12, it is 4.13, 4.14, 4.15, 4.16, this is 4.17, 4.18, 4.19. But the number is 4.125. See, it lies between 4.12, more than 12 and less than 13. See, 4.12 this is, and 4.1. We can write 4.120 and this is 4.130. Now we can write it as 4.121, 4.122, 4.123, 4.124, 4.125, 4.126, 4.127, 4.128, 4.129. Followed? The number is 4.125. This is here. You can mark like this. This is the way to represent. But in the successive magnification, we are going to use magnifying glass. That should be shown. Okay. See, when you place magnifying glass on 4 and 5, we get the enlarged part. That it is here. This is magnifying glass. Next, 4.1 and 4.2. This is magnifying glass. 4.12, 4.13. Then this is 4.125. Clear? Next we have operations of irrational numbers. Hope that you are able to do them. They are very simple. So with this, the revision on the first chapter, number system, is over. Next we are moving to another one, that is polynomials.